Hello everybody, this is Charles Anderson, and I'm just a guy from Goodwill with a really great video game idea. It is, what, the fourth, the fifth? I don't know. I know that this final part, because I chose to include the break and the continue statements in on this, I've actually had to look at my time and say, wow, that seriously needs to be a part 3 in this. So this was going to be 2 of 2. It's going to be 2 of 3 now. So we're in part 4, Flow Controller in Java 2. So part 5 will contain part 3. Go figure. All right, but for this one, our prerequisites are Flow Control 1 and code. So you've got to have gone through Flow Control 1 and the code. And are you ready? Let's go. Now, before I even start, I realized something. And it had to do, and you'll notice I have the full, well, let's see, beginner. Yeah, that's where I'm at. This one's a backup just in case I mess up this take. Yes, indeed. Alright, so, beginner Java, that's where we're at. Beginner Java. Bam, there it is. Okay, so last time I was like, well, remember you gotta track your booleans if you're going to use booleans in a boolean expression. And then, I had one of those duh moments where I realized I really don't need this if I use this instead, because it's not going to change from here to there. Yeesh. So, where you can optimize, and now I've just reduced to the lines of code. Now, I've reduced the lines of code, and I've made this take a little bit longer, okay, as far as time-wise, because it's got to kind of do this jump over and do this code over here and then jump back. But as far as the size of the file, it's down. The speed of the file is down. So this is just a minor trade-off. It's hardly noticeable from our level, but once you get into more complex things, yes, having a straight-up Boolean that you track, you've increased the size of your code, you've increased the lines of your code, but you have increased the speed at which it runs because, evaluating a Boolean is way quicker than evaluating a Boolean expression. So that's the trade-off. I needed to make note of that. Boom, done. So with that, which is exactly that code that, from the last one, bam. Alright, so we're right there. Now, this is the full one with, this is the world's worst, most hilarious counter. So, yeah, that's what this code that I'll be typing up will eventually become. But we're still in the beginner one, so I'm not, during the intermediate phase of this beginner's, basic course, I will just go ahead and have the code out there for time as we get into the more advanced topics. But, for now, I'll still keep typing. And, just be ready for when I start analyzing code, because I'll follow the flow, but I have to tell how flow goes before I can start jumping through flow in a program, just reading it for you. So, alright. Let's see. So I'm going to, this is the world's worst hilarious working counter ever, in my opinion, because you can easily make this thing so annoying. And part of the learning process is, just what a pain in the butt tracking breaks and continues for the loops are. Return actually is pretty easy. And let's see, try, throw, catch, and finally, which are special keywords that work in conjunction with each other. Yeah, throw is definitely a monkey all in and of itself. So, okay, counting number and scanner. We'll start with this for our base code, because I'm going to actually be cherry-picking the lines that keep this from being a pain. So, counting number, scanner, okay, and of course we've still got our scanner here. So, I typed those in. Now let's cherry-pick out the lines which are still relevant. Alright. We're making the pretty nice way that it's supposed to go to be one of the better counters, okay? Alright. So, we've got our counting number declared and set. We've got our scanner declared and set. Alright, system out. I count from 1 to a number. Yay! System out print, please enter a number. And then on that line, they'll type in a number. Okay. So then our program's going to start counting up to that number. So now to cherry pick out. Okay, here I go. Oh, right. I also explained the ternary operator. Okay. So I will cherry pick out that code too. All right. So yes, we're still now string one character. Of course, a string is a string, but I only use it for one character, difference to make it pretty, and I use a ternary operator to do that. But let's see here. I'll cherry pick out this one. All right. There's my for loop, and of course we've got a for loop, so I can go back and jump in to my explanation. All right. The for statement. The for statement is used to naturally loop through code a predetermined number of times. Now, why do I not say like it's not, to naturally not do it? Well, a for statement, when properly used, it is supposed to go through a predetermined number of times. If you program it wrong, it will A, not execute, or B, execute to infinity. So that's why it's a little bit more advanced than the while or do while, because you're using an integer. And though an integer is involved, the loop is active for a Boolean expression of true. You're just using an integer to key off this Boolean expression of true. So it's a very specific type of loop. And this is a way to loop x times in program floor. So let's show the proper way to do the basic for loop. And there is an advanced, or I guess enhanced, way of doing a for loop, and that has to do with arrays and lists or objects of iterable type. So for those who know, yeah, they know. Oh, right, I guess I didn't need that bracket. Okay, so now I'm going to go back to cherry picking. Okay, this is good. This is good. This is good. Okay. Oh, there we are. Nope, that's the one that I want. Okay. I just needed to switch over here. Alright, so let's take these lines of code one at a time. Alright, so for int I. Alright, the for has 3 statements in its little braces here. The first one is the declaration and initialization of I, or well, not I mean it's whatever you want to name it, but this is the primitive of integer type that you declare. It's, that's the type that it's got to be, and there we are. Now here is the Boolean expression that it checks against. Okay, and so while this will activate while I is less than counting number. So we're going to start with 1, and we're going to go from this initial value here, and this has got to remain true for however many times it does. Once this becomes false, it stops working. Now for this, because I'm counting up to a number, I'm using an incrementer. Okay, and all this incrementer means is equals I plus 1. Okay, that's all that means. And it happens afterwards. Of course, I'll go more into incrementers and decrementers as well, but I'll go ahead and show other quick, valid ways of saying the exact same thing. You could just also say plus equals 1. Totally valid. That means I plus equals I, I equals I plus 1. That's what that operator is saying. And of course, the one after this series will be the operators to finish up the base of Java. All right, so I plus plus. Now what? Oh, I hit page down. All right, so plus plus. There we are. Okay, so first we're going to print off I. All right, this is our number while we're counting. And I put in like a little comma here. And next up, we have a statement which introduces the ternary operator. So one character, that's a string, equals a Boolean expression. All right. Now I'll unwind this Boolean expression here. Something equals 0. All right. Now here, I've done a little math equation which gives a result of type integer, because I is an integer, uses an integer. And it has to do with this little symbol right here, which is the modulus. What it's going to do is it's going to divide I by 10. Okay? So a lot of the times it's going to be 0. Well, it's going to start off, obviously, at 0, and with a remainder of 1, 0 with a remainder of 2, 0 remainder of 3. We're interested in the remainder. So that's how we work with integers, modulus, the remainder. So every time that the remainder lines up with 0, then it does this evaluation. So if the remainder equals 0, if here's the if, signifying if, then it will equal this character. So every 10 digits is going to equal a new line. And else, right here, it's just going to be a space. So, I already have, this is from the evil one. Okay, so that's what that's going to do. And system out, print one character. So we can actually run this right now and let you see what this amount of code does. So let's play it. I count from 1 up to a number. Please enter a number. Alright, so let's go 5. Okay, 1, 2, 3, 4. Oh, where's 5? Well, that has to do with this right here. If I go like this, now equals is added to it, so I can play that again. 5. Okay, 1, 2, 3, 4, 5. And you know what? I don't like a comma, so I will just go like this. Print line. Let's do a system print line. Oh wait, right. Cherry pick it, dude. Why don't I just cherry pick it? All right, there we go. Oop. And of course, I'll have to alter it back because that's the evil program. I can just do like this. And there we go. That's pretty. Counting number. Okay, and I can just revert this back to just the less n. So, also of note, for this declaration right here, once you leave this loop, I is no longer valid. That's why you usually just do like a little I, or J, K, or X, Y, or Z for this one right here, because it's not going to exist once you get outside of this for statement right here. Well, there we go. Oh no, don't you move. Okay, so there we go. Now here's the pretty version. 5. 1, 2, 3, 4, and 5. Bam. There we go. So our counting program is being nice. Oh, right, and it because of the modulus 10. I need to show off the modulus 10 because it's normally equaling this because this isn't triggering. All right, so I will run, and let's count up to what, 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom, 11 and 12. So yeah, pretty cool stuff, huh? So yes, here is a for statement as it's properly written. I will mention that this statement, and this statement are all optional statements. You can have a for statement with just two semicolons and everything else blank. However, it will run forever. And so you'd have to know break, and you'd have to make sure to declare a control variable outside, and you would have to put in a break statement that operates on this, and an if statement, and you would need an incrementer statement somewhere in here. So this would have to go up here, this and this would have to go somewhere in here and track properly. So I'm not going to go into that. The evil program goes into that. All right. And even then, not that. I just have to mention it. Okay. So, next up. Now that our program is counted, let's do a quick proper switch. Oh, right. Come on. All right. Switch is up next. And we will do a rating system for how well our program counted up to whatever number that you choose. Of course, naturally, if you put a negative number, it's just going to, yeah, whatevs, and then leave. But the switch statement is used to exclude multiple lines of code, by my definition, by properly programmed. It can be viewed as a shorthand way of doing if-then-else statements. Me, I prefer if-then-else, one option or the other, to mutually exclude stuff. If you need to do like an or, if you need to filter stuff down, then you can just use if statements. But, I tend to try to do if-else, if-then-else. That's just my thing. Now, this relies on a value. It does not have to be an integer. I use integers. It can rely on strings. It can rely on pretty much any class or primitive that you want. But however, the case default keywords choose if this equals this, then do this case. Default is if none of them equal. So this is a Boolean expression true, but properly worded, it only activates on an equals of that value. So yeah, you can't really use comparators for your cases, I don't think, at this time. I'm learning as I'm explaining, so bear with if possible. And break. Okay. Break is the ultimate flow control for the switch and keeps things nice and tidy. This is used to skip in flow control. All right, so let's bring it over. Yes, jMonkeyEngine. Okay, so let's go grab stuff from this thing here. Okay, so we declare a rating number that we want. Okay, cherry pick that one out. Okay, oh, and by the way, you can declare variables anywhere that you want. I declared this one here to separate my next major section of code. It is handy to be able to declare them wherever you want. However, if you declare them down here, you cannot use them up here. If I were to say, let's see, rating number is what it's called? This throws an immediate compiler error because can't find it. you can only use something after you declare it. That has to do with the natural flow of code. So, if I forgot to mention that, my bad, but I'm mentioning it now. So, it all has to do with flow code. And that's why I'm throwing this stuff down here, is to show you what not to do. Or if you have a problem, you'll probably be able to find it easier just because I mentioned it. All the things that I'm not mentioning and or mentioning incorrectly. Okay, so here we go. And now we're going to have these next strings codes. Now I have not gone too horribly into this one, so I can just cherry pick pretty easily on this one. Alright. However, I do know how I'm going to go in depth on it, so that one's going to look fun too. Alright, so we declare our variables. We don't need Guardian. And it's probably best to move this up here. Although it will be down there later. Alright, so what I'm going to do is I'm going to have the user to enter a number. Oh, I guess that's why I have it down there. Alright. So our user enters their number, so we have that. Now we're getting ready to go into our switch statement. And for my switch, because I wanted an ending tag to, ultimately display how a switch statement works, yeah. Alright, so here we go. Here's our whole switch statement, and I'll just grab that and pull it over. And I will immediately start pulling out all the pulling out all the breaks. Alright. Yep, I won't be needing Guardian. I definitely won't be needing a label yet. That's why I'm going to go into... Yep, won't need... Oh, there's little... Yeah. Alright, where's any ending tag, break, regular breaks, and have I removed all the labels? I have moved all the labels. Okay. Alright, so this is a switch statement. It starts off like this, and it's kind of like a if statement. I mean, it's really shorthand way of saying an if statement to me, but it's a very special type of if statement where it only compares if it equals. So rating number, this is the number that they typed in, and our cases that we're worrying about is 1 through 7. So if we properly handle our code, it will go through 1 through 7. Now, I've started my opening brackets there. There's my ending brackets. And when we want to do the comparison, here's the value. And we're going to compare this value to this one. Alright? And so, like, if this were, when this equals that, then it goes in here. It goes down the line, and so it'll stop here. Oh, case 1. Alright, well, print out horrible. So the whole thing will be print. No, not print line. That just needs to be print. Mental note. Need to fix that. Okay. I did a, and then it'll come down here, and then it'll put print horrible, and then this ending tag will become I'm sorry. With some dots, and then it'll break. And let's go ahead and show that in action. Wait, did I get job? Yeah, I did. Okay, cool. Alright, so we'll play it. Alright. Well, we know it'll count to 3. So, how did I do? Alright, well, we're going to target 1 right off the bat to show you. Okay, got it. That means I did a horrible job. I'm sorry. And, that's how that thing patches together. So this is just me playing with a little thing, but it demonstrates this is the proper way to do something the way that I did it, because I could just say I did a horrible job, and then I'm sorry. But because I wanted to have some text, a little bit of text, then some other text, plus some other text, then I'm breaking it up. There we go. So I could say I did a horrible job. I'm sorry as one long line, but this is to support other stuff. All right, now, what if we forget this important break? Because this break, it means, here if I highlight it, okay, you'll see that switch is highlighted. When I break, it's going to come up here, go to the end, there we are, and then continue on. That's what break does, without a label. So break, there we are, go. And break only works in switch. No, go into that on the next one. Okay, got it. All right, so now you'll see case 2 and case 3, they don't have break. All right? And in case 2, case 2, case 3, case 4 doesn't have a break. So, do you want to see what happens? I guess the easiest way to show is to run through it. I'll start from case 4, work backwards to case 2. All right, I count from 1 to a number. Please enter a number. 4. Okay. Enter. Oh, right, that's not the right one. Okay, 4. Okay, I got it. That means I did a job. Okay, so it comes into the switch. It's not 1, it's not 2, it's not 3. It's 4. Ending tag plus equals a period. Well, I set it to null here, so all that happens is I did a job plus ending tag, period. So that's how that worked. Now, if I play this and go 3, okay, so how did I do? Well, you did a 3. Yes, 3. Okay, I got it. That means I did a poor job. Okay, so it comes down here to 3. All right, starts in. System out print poor. Okay, so it prints poor. So I did a poor, and then because there's no break, it ignores this case. It just keeps going. Bam. Ending tag plus equals period, and then there's the break. So and then job plus ending tag. So I did a poor job, and then the ending tag. All right, and then finally 2. Okay, and you did a 2. I did a really poor job. Aww. Okay, so this looks pretty cool. The 3 dots and the 3 dots. I did a really poor job. Aww. Okay, so let's follow it through. I did a. All right, comes in here. Here's case 2. So it prints out really. Okay, so there's really. Oh wait, no. It's like, yeah, really. And then ending tag becomes aw dot dot dot, or well dot 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 aw dot dot. Okay, so that's this right here. Oops, come on, highlight that. There we go. And then it continues on. Case 3, system out print. So it prints this. Poor. Okay, then we keep on going. Ending tag plus that. So there's that, making this total for the ending tag. Alright. And then it breaks. Doop. Doop. And now we have job plus ending tag. So that's how it puts together, I did a really poor job, aw. And it looks all correct to the end user, but we really know what's going on. So here's what happens if you do not put break in. It will just go, it will hit the first case, and then keep on going. And now to make fun of this, for case 5 and 6, I've put something that doesn't... Oh, that's in the evil program. Okay. We'll mess it up for this example, though. I mean, let's go ahead and do 5. Okay, here I go. 1, 2, 3, 4, and 5. So how did I do? Well, you get a 5 now. We made it up to the next level. Okay, got it. That means I did a super job. Hey, thanks. Okay. And then let's hit number 6. Okay, here I go. 1, 2, 3, 4, 5, and 6. So how did I do? Well, you get a 6 this time, little program. Okay, I got it. That means I did a super duper job. Wow. So, of course, this ain't nothing big. It prints super. Hey, thanks. You know, super duper, and wow. So there's super duper, and there's wow. You know, just like that. Now, and this is hilarious. I'm going to go duper. All right. Because hey, we can erase this break right here. Let's erase this break. All right. And now we know that we know that if we do 5, it's going to print out super, and if we do 6, it's going to have duper in there as well. Oh. So let's play it. All right, please enter a number. All right, 5. And 5, you did super. I did a super duper job. Wow. Oh, let me erase this. Yeah, there we go. Now it'll look great. Please enter a number. I did it. I'm off of the charts. Woo. Job. Okay. Let's see. 5. Okay, I got it. I did a super duper job. Wow. Well, that's definitely what we wanted for 6. And and guess what? Because this one overwrites ending tag. You know, hey, thanks. that's what's happening. It's just overriding it because there's no break there. The super duper is working for the wrong one. You know, that's one of the things you have to consider. You might have a really cool idea, but how far are you going to take this? Well, in this one, I can't resist it. I can't resist it. If let's see here. Oh, because we know that we want wow on number 6. So if rating number equals 6, which is kind of what this is saying. All right. Oh, don't want to close off my break. That would be bad. That would be very bad. All right. All right. Now, at least we've fixed the ending tag. So how did I do? I did a super duper job. Hey, thanks. There we go. And of course, if I do 6, you do 6. I did a duper job. Wow. Yeah. Okay. So there you go. Sometimes, like really poor. If you just have poor, then really becomes awesome. You know, I mean, really poor. This works because really adding really to poor in sequence is great. However, you have super and then duper. Well, super's the one that's needed in both of them, and it's duper that gets, you know, added. So, yeah. Don't worry, we'll take care of that in the next sample for breaks. But I've shown that to you, and I can just go ahead and go. Go ahead and add the break back again. And if I just add super here, I'm going ahead delete that, pull that over, get rid of that line, get rid of that line. All right, there we go. And then, of course, system out print. Excellent. And poetry time. I will not go into the poem. Oh, all right. Oh, cancel. Where am I? Oh, all right. Let's go. I'm gonna get through this sample. I've got to get this done. All right. And to get this done, I need to come down here. All right. So we're hitting case 7. Pretty standard. Oh, 7. Okay, got it. I did an excellent job. Poetry time. All right. Yes, I will go ahead and spoil it for you because this program is so evil. I have to. Yeah, I had to write a poem. So that will be in the next section. But there we go. Case, break, and why it needs break. Now, normally, I would go into break, continue, return statements. Okay? And yes, break is meant to exclude line of codes or backtrack if labeled. Continue is meant to exclude lines of code. So wherever you put continue at, it stops going through lines of code and then jumps back to the evaluation for the statement and starts through it again. So these two are pretty much solely going to be the topic for the next thing because of the time. Return, this one's easy. It's to jump from a block of code containing a value if specified, back to a calling method. So like, come on, where's jMonkey? Just to give a quick outline because I'll go into more in this on classes. All right, where was it? Oh, right, it would be in where I retained the code. Yes, I know I should have kept you. Fire up, where are you at? Where are you at? Come on, beginner Java. Okay, there we are. Okay, so like this evaluation right here, this equals, come on, highlight. It returns a Boolean value, which is a valid Boolean expression. So in this method, this is the calling method, it will return, Boolean. So I'll leave return being used with calling class method, and that's that. You don't have to understand it any further than that. You're fine. Now, the big thing that I want to express when using break, when using continue, when using return, there is no Boolean expression to evaluate these. These will jump. And Java does not have a goto statement. Right? It uses these break, continues, returns, and limits them to specific instances to try to keep people from doing random goto statements and messing up their codes. So, you have been warned. Okay, and this is used to backtrack, skip, jump, and flow control. I have now explained break. I will be going on next week. I'll go ahead and put up my credit screen here. Yeah, well, my next one will be part 5, Express 3, and I'm even going to be using this one for part 2. Go figure. It's just going to be one frame, but oh my goodness, the evil program that is just too hilarious for me to even spend the time doing, in this one. So, okay, I'm Charles Anderson, indie game developer. My project's Idiog. I've got an email. I've got a Twitter. And this is part 4. Y'all have a good one. Catch you later.